Hi, everybody. I've really been looking forward to this section. This is in linear functions. This is the S section, and this is graphing using slope-intercept form. So we're going to be graphing the intercept and then counting the slope, most likely. Anyway, I haven't previewed it much, so hopefully it's going to be fun. It's S7. Let's see how it looks. I may write the equation on this side because once I bring my graph up, you won't be able to see the equation. So I'm going to go ahead and write it over here. So it's y equals negative 5x plus 4. And I'll be able to work with it a little bit more easily. So anyway, let's see. We've got an intercept at 0, 4, and that's right there. And we have a slope of negative 5 over 1. So that means that from that point, I'm going to go down 1, 2, 3, 4, 5, and over 1. And that's going to give me a slope of negative 5 over 1. Now, it just so happens that you can count it the other way. You can go up 5 and back 1. Take a look. I could go up 1, 2, 3, 4, 5, and back 1, and I'll still be at the same, still have the same equation, okay? Because the slope is negative 5 over 1, which happens to be the same as positive 5 over negative 1. There are times when you're going to want to be able to use this method instead of this one, and it counts both ways. Either way is correct. This one is y equals 1/6 x plus 6. We'll move it up a little bit. Okay, so we're going to go through 0, 6. There's the y-intercept, and I think I might have accidentally turned it off. Let's make sure it's in there. And I'm going to go down 1, sorry, up 1 and over 6. This is not very steep. I'm going to go up 1 and over. Oh, dang it. 1, 2, 3, 4, 5, 6. It's kind of cool that you can see it getting less and less steep as you go across. This is the same, by the way, as, interestingly enough, I could write the slope as 1 over 6 or negative 1 over negative 6, meaning I could go down 1 and back 6. And hopefully you guys can see that if from here I go down 1 and back 6, I end up on the same line. Let me make sure I'm actually went back 6. I think I got to go one more. There it is. So 1/6 x plus 6. Graph another one. This one, notice, is written a little bit funky there. They wrote the negative out in front of the fraction, in front of the slope. It would be better to write it with the numerator, but it's not wrong to put it with the denominator. It's just very confusing to try to write it on the outside of the division line. Anyway, there it is. Let's move, oh, get rid of that, sorry. Let's get rid of this guy, there we go. Okay, so we'll move it up. Now I'm going to start at 0, negative 6. That's my y-intercept right there. And we're going to go down 1 and over 8. That's down 1 and over 1, 2, 3, 4, 5, 6, 7, 8. And it's the same as going up 1 and back 8. But there we have it. Looks like, yeah, I'm an 8. This is really good practice for everybody who needs to practice their slope-intercept form. This is y equals 1/9 x minus 4. Now, I want to point something out, and so to speak, I want to point something out. You'll see the joke in a minute. I could choose 0, negative 4 as one of the points and then count the slope from there. This is normally what most people do. And in fact, that's what they're asking you to do in this particular problem. But I want to point out that I could, if I wanted to. I don't have to choose 0 for x. I can choose any number I want for x. Now, if I choose 0 for x, then of course, x is 0 and y is equal to negative 4. But look what would happen if I chose, for example, 9 for x. If I substitute 9 into this equation, the 9's cancel out and I get 1 minus 4, which is negative 3. This is another point that's on my graph, and I could just as easily have started at this point instead of this one. The reason that we chose this point is because it's really easy to calculate. When you substitute a 0 in for x, when I put a 0 in here, it's just 0 minus 4, which is negative 4. And you're always going to get this value, which is the value of your y-intercept. That's why we do it. Anyway, we're going through 0, negative 4. And we have a slope of 1/9. Now keep in mind, we're going to go up 1, go up 1 and over 9 from here. So we go up 1 and over 9, which puts us right there. Of course, I could go down 1 and back 9, but there it is. Let's see what our next one says. Y equals negative 4x minus 3. Go ahead and write it. Now I could use any 2 points, and it just happens that 0, negative 3 is an easy point to find. 0, negative 3 is my y-intercept, and I'm going to count my slope. Now my slope says negative 4, but that's really negative 4 over 1. So I'm going to go down 4 from here. A very common mistake is to start counting slope from the origin. You always count from one of your points to another. So to get from 0, negative 3 to another point, I can count down 4 from here. From here. 1, 2, 3, 4, and over 1. And this is a slope of negative 4. Now, sometimes this isn't going to fit on your graph. So another option is, instead of counting your slope, down 4 over 1 to the right, I could go up 4 and back 1 to the left, which would be from here, go up, from here, go up 1 to, oh, I can't do it that way. I have to, let me restart it here. Let me get rid of this one for a second. So I'm starting here, and I can go up 1, 2, 3, 4, and back 1. And I'll still have a slope of negative 4. So just wanted to point that out. This one is y equals 1/7 x plus 2. And I'll get rid of that. So we're going to go through 0, 2. There's our y-intercept, and we have a slope of 1/7. This is a positive slope. That means it needs to be going uphill, something you want to keep in mind. I'm going to go up 1 and over 1, 2, 3, 4, 5, 6, 7. And I can see that it lines up with the 7 over there, so I'm good. And I'll just keep going because I'm sure you want to get it done. So this one is going to be y equals 5 over 1 x. And you can always put the 1 if you like or not. Minus 9. And get rid of this. And let's go to 0, negative 9. And here's a good point. If this had been a negative slope, do you see why I sometimes count it backwards? Because you're not going to be able to count down from here. You'd have to count up. It just so happens that this one's a positive slope. So from here, I'm going to go up 1, 2, 3, 4, 5, and over 1. And I'm going to have my slope of 5. By the way, you could count up again 5 and over 1 and up 5 and over 1 and get lots of points for your solutions. And that's always a good idea, especially when you're testing to draw your line. That way it's nice and straight. There it is. This one is y equals negative 1 over 7x plus 8. And I'll get rid of that. So we're going through 0, 8. And we have a slope of down 1 and over 1, 2, 3, 4, 5, 6, 7. And it looks like a negative 1/7 x plus 8. This one is 2x plus 2. I'm going to go fast. I'm going to go through 0, 2, and I'm going to count a slope of up 2 and over 1, and I'm done. It is that easy, really. This one has a y-intercept at 0, -6, and it's not going to fit on my graph, so I'm going to go ahead and write it. Y equals 1/4 x minus 6. So I'm at 0, -6, and I have a slope of 1/4. That's up 1 and over 1, 2, 3, 4. Oop, I had it. There it is. On this one, we have a y-intercept at 0, -9. I'm gonna revisit something I said before. Y equals 3x minus 9. I just want to make sure that this is clear to everybody, and something that a lot of people get confused about. I don't have to choose 0 for my point, but I can. The reason I like 0 is because it's easy. 0 times 3 is still 0, and then that gives me y equals -9, which is always this point. No matter what coefficient you have, if you put a 0 in for x, you're going to get this constant as your b value. Now, I didn't have to choose 0. I could have chosen 2. 2 times 3 is 6 minus 9. If I substitute 2 for x, I get 3 times 2 minus 9 is what y is equal to. What I did was I substituted 2 for x. 6 minus 9 is -3. I could have used this point. I could have started there. I could have used 3. Well, let's see. What happens if I put in 3? I get 0. 3, 0. This just happens to be what's called the x-intercept. This one is called the y-intercept. They are different things. They're really easy to get confused, but here's a way to always tell which axis you're on. Hopefully everybody notices that that -9 is a y value. Well, a y value with a 0 tells you you're on the y-axis, and it's called the y-intercept, and it's going to have a y value, y. Same thing with the x. This is this 3, 0, that x is a 3, and it's an x value. It's on the x-axis, and it's called an x-intercept, x. So anyway, so let's see, 3, 0 is right there. 0, -9 is right there. And I just graphed the intercepts. Now, I didn't have to do that. I could have counted my slope, which is up 3 over 1, from any of these points. I could have started at this point. I could have started at this point. I could have started at that point. It wouldn't matter. Any of those points, if you go up 3 and over 1 and up 3 and over 1, you'll find your another point. So we got this time. We got y equals 3/2 x minus 2. And I'll get rid of that. So we're going through 0, -2. And we have a slope of up 3, 1, 2, 3, and over 2. Now, I could have chosen that point, but I could have just as, like I said, I could have just as easily chosen any even number, and it would work out nice and evenly. I could go up another 3 and over another 2 and go there, or I could go up another 3 and over another 2 and go there. Any of these points is on my line. And submit. This one, we're going to go through 0, -6. Oh, it helps if I write it. Y equals 1/10 x minus 6. So we're going through 0, -6, and we have a slope of 1/10. That's up 1 and over 10. And we're all the way over here. So it's a very, very shallow slope, or not very steep. It's only got a 1/10 slope on it. And let's see. This one has a -1/4 slope. Notice it's going to be going downhill. Y is equal to -1/4 x plus 7. And get rid of this. We'll go through 0, 7. and it has a slope of negative 1/4. That's down 1 and over 1, 2, 3, 4. There it is. And you could count it again and again and again. And of course, you could go up 1 and back 4. It's still going to be at the same place. If I go up 1 and back 1, 2, 3, 4, it's going to be there. And of course, it's still going to be on my graph, isn't it? This one, y equals 6x minus 8. I'm just going to go ahead and work through them here pretty quickly. Sorry, that's not very neat. There, that looks better. All right, we're going through 0, negative 8, and we have a slope of 6. That's up 1, 2, 3, 4, 5, 6 over 1, and there it is. This time we have y equals 1/8 x plus 9. We're going to go through 0, 9, and then have a slope of 1/8. 0, 9 is located right there, and up 1 and over 8 is going to be located right about there, I believe. Oh, I think I'm off by 1. There it is. Really easy to fix this. This is a really nice graphing program. Let's see, we've got y equals negative 9 over 8x plus 6. And we can go through 0, 6, and we have a slope of down 9. To go down 9 is going to put us at negative 3, isn't it? Don't have to necessarily count if you can figure that out. And I'm going to go over 8. I'm going to be right there. Now you could count it. It's better to think about 6 minus 9 is negative 3, and you're going to be down here. This time we have y equals negative 1 over 6x minus 3. So I'm going to go through 0, negative 3. 0, negative 3 is there, and then I'm going to go down 3 and over 1, and I'm done. That's all there is to it. Oh, sorry. Go down 1 and over 6, and that's all there is to it. Down 1 and over 1, 2, 3, 4, 5, 6. There we go. Easy to make a mistake if you're not paying attention. By the way, the slope of negative 1 over 6 is the same as the slope of up 1, back 6, which would be up 1 and to the left 6, which would be there. On this one, we've got y equals negative 4 over 9x minus 2. We're going to go through 0, negative 2, and it's going to go down 4 and over 9 to get to the next point. So down 4 and over 9 puts us right about there. Yep, there it is. Looks like we're getting there. And we have y equals negative 1/3 x plus 3. And let me get rid of that. Okay, so we've got a 0, 3 as a possible point. Again, if I wanted to choose some x's other than 0, I would want to choose multiples of 3, because there's that 3 down there that would make it a whole number. If it was 3, 6, 9, I could put in any of those points. In order to graph this, I'm going to go down 1 and over 3. That's down 1 and over 1, 2, 3. I could go down 1 and over 3 more. I could go down 1 and over 3 more. And I have lots of choices here. In this one, we've got y equals negative 7 over 10 x minus 1. So I'm going through 0, negative 1, if I like. 0, negative 1 is located right there. And from there, I'm going to go down 7 and over 10, which is way over there. That is down 7 over 10. And in this one, we've got y equals negative 2/3 x minus 4. So we're going through 0, negative 4. And we have a slope of 2/3, negative 2/3, excuse me, down 2 and over 3. I could go down 2 and over 3 more. I could go down 2 and over 3 more. Hopefully you can see where I'm moving those points to. It doesn't matter. Any of those points are going to work. I could also go up 2 and back 3, which would also work. If I go up 2 and back 1, 2, 3, I'm still going to be on my line, aren't I? By the way, if I wanted the x-intercept, let's see where it is. Up 2 and back 3, there's my x-intercept at negative 6, 0. My y-intercept is here at 0, negative 4. And let's say we've got y equals negative 8 over 7 x plus 6. We're at 0, 6 is a possible point. I could choose any multiple of 7 and find some other points. I'm going to go down 8 and over 7. That would be down 8 and over 7, which would put me there. And that's it. I really can't go up 8 and back 7, but I'm good to go. Let's see what the next one says. Y equals negative 8, if you like, over 1, same thing, plus 4. It's helpful sometimes to write it as a ratio because you're going to be counting the slope. So I'm going to go to 0, 4. That's one of the points on my graph. And from there, I'm going to go down 8 and over 1. It's going to put me right there. And I'm done. Notice a negative 8 slope is very steep, but it is going downhill. And we're getting there. This one is y equals negative 1 over 9 x minus 4. Kind of funky looking 9 there. It's not much better now. All right, we're going to go through 0, negative 4, and we have a slope of down 1 and over 9, and there it is, all done. You could go up 1 and back 9, same thing. And 9x minus 9. So we're going through 0, negative 9. There it is. And again, I could have chosen 2 or 1. I could choose any number I want for x. I happen to choose 0, which is nice. And I'm going to go up 9 and over 1, which is right there. And I could go up 9 and over another 1, which is right there. And any of those points will work. That is a very steep slope, isn't it? And it's going through 0, negative 9. And it looks like we're on our last one. So let's see what it is. Y equals negative 1/5 x minus 8. I'm going to go through 0, negative 8. Let's get rid of that. 0, negative 8, and I have a slope of down 1 and over 5. It's right there. And it looks like we might be done. Let's take a look and see. Nope, get one more. This one is going to go through, I'm going to go ahead and write it. Y equals 2/3 x minus 6. We're going to go through 0, negative 6, of course, is our y-intercept. And we have a slope of 2/3, that is positive, up 2 and over 3. And again, I could go up 2 and over 3 more. I could go up 2 and over 3 more and get my x-intercept, which is at 9, 0. Anyway, there it is. Hope you guys like it as much as I did. I really enjoyed this one. Hope you'll all go to 100% as well. And I'll see you back. Bye, everybody. There we go.